Alright class, in this particular video we're going to be looking at systems of equations. So two variable systems. A system of equation is two or more equations with the same number of variables. So we're going to be talking about 2 by 2s and 3 by 3s, meaning two equations, two variables. And we're also going to talk about 3 by 3 systems, so 3 equations, 3 variables. The solution to a system of equations with two variables is the ordered pair x comma y that satisfies both equations. So it has to be true for both of the equations in order for it to be a solution of the system of equation. Linear systems have either one solution, no solution, or infinitely many solutions. And we're going to talk about what these solutions look like in the following examples. There are 3 ways to go about solving systems of equations, and we're going to start off by solving them graphically. So here in this example we have our 2 equations here, so we're going to go ahead and solve these. We're going to first start off by transforming them into y equals mx plus b form. And so when we solve this, we want to get y equals, and we're going to move everything over. So moving over the -3 and then dividing by a negative is going to give us y equals 3x plus 5. And if we change this equation, we're going to end up with y equals 4x minus 2. Alright, so let's go ahead and graph this. I'm going to start off with the first one. I'll graph them in 2 different colors. Let's start off with red. Start off at plus 5, so 1, 2, 3, 4, 5. I call this y-axis, here's my x-axis, and then from here we're going to go up 3 over 1, so 1, 2, 3 over 1, and we're going to go down 3, 1, 2, 3 over 1. So we're going to have, oops, we're going to have a line that looks like this. Nope, it didn't. Let's see if I can draw a straight line here. Okay, so it goes on like that. Alright, so now my other line, let's draw that one in blue. I'm going to start off at -2, so here's 1, 2, -2, and then we are going to go have a positive 4 slope, so we're going to go up 4, 1, 2, 3, 4 over 1. Up 4, 1, 2, 3, 4 over 1. We're also going to go down 4, 1, 2, 3, 4 over 1. So we have a line that looks like this. So the solution to this is going to be anywhere that they intersect. So notice that both of these lines are intersecting here. And this point is -1, comma 2. So that solution is going to be located -1, comma 2. So that's the solution to this set. Alright, let's look at this next one. So here we have y equals, actually let's rewrite the first one. So we have x minus 2y equals 8, and that's going to translate into y equals 1/2 x minus 4, and then we also have x equals -6. Here's our y value, here's our x value, right, our x-axis and our y-axis. So let's go ahead and graph the first one. So we're going to start off at -4. So here's 1, 2, 3, 4, negative, right, because this is our origin. And we're going to go up 1 over 2. So here's 1, 1, 2. I'm also going to go down 1 over 2, 1, 2. Okay, so I'm going to have a line that looks like this. Right about that. And then my other line is x equals 6, -6. So here's 1, 3, 4, 5, 6. So then that is just going to be a straight line here. And so this is the line x equals -6. So that means that our graphs are intersecting here. And this point is going to be, it looks like -6, comma 7, -7. Okay. And again, that's because here we're at -7. And then this was the value -6. All right, let's take a look at the next two. Oh, let me actually take a step back here real quick. Both of these, because they intersect, right, these systems, both of these are considered to have one solution. Sometimes this is also said as a unique solution. So that is one type of solution that we can have. Let's take a look at these two. So I'm going to go ahead and rewrite this. And so when I rewrite this, I'm going to end up with y equals x plus 5. And this one's going to turn into y equals x minus 2. All right, let's graph the first one first. I'm going to start off at +5. So here's 1, 2, 3, 4, 5. This is my y-axis, my x-axis. And then I'm going to have 1 over 1. So 1 over 1. So it's going to look like this. So, all right, let's see if I can draw a line there. Okay, so here's my graph. Let's look at the next line. It's going to be at -2, so here's 1, 2, but it's going to be at 1 over 1, 2. All right. So now remember, the solution to a system of equation is where the lines intersect. Because there is no intersection of these two lines, right? They are what we call parallel lines. So because they are parallel lines, we say that there is no solution. Sometimes you see that no solution is written as an empty set like this. So that's an option. But this, again, this is because we have parallel lines, this is considered not having a solution. Okay. All right, let's take a look at this one. So we're going to rewrite this. This is going to become y equals -2/3 x plus 3. And when we rewrite this, this one becomes y equals -2/3 x plus 3. So they are really just a multiple of each other. So if I took this first function and I multiplied it by 2, I would end up with the same values in that second function. So because of that, they end up graphing the same exact line. And so, you know, if I were to graph this +3, so here's 1, 2, 3, I'm going to have a negative slope, so I'm going to go down to 1, 2 over 3, 1, 2, 3, up to 1, 2 over 3, 1, 2, 3. I'm going to have a line that looks like this, but that second line is that same exact line. So meaning that when I graph it, I'm just basically graphing right on top of it. So how many times do they intersect? Well, they intersect infinitely many times. So in this particular case, we would say there are infinite solutions. And this happens when we have the same line. So like we said earlier, there are 3 different types of solutions, right? So if we come back up here, we have one solution, or what we call a unique solution, no solution, and infinitely many solutions. And that's what we just saw in these 3 particular graphs.